Hello everybody. Today we will be talking about properties of integer exponents. Our standard for today is know and apply the properties of integer exponents to generate equivalent numerical expressions. I have provided two handouts of notes that you may refer to as you watch this video. If you view the first handout, it will say Math Planet and it will say Properties of Exponents at the top. And we will begin. Whether you're multiplying, subtracting, dividing, or adding numbers with exponents, you're doing something different with the exponents every time. When you are multiplying numbers that have the same base but they have exponents, you add the exponents as long as the base is the same. So if you look at the handout, the first handout, you see it says x to the fourth power times x squared. Since you're multiplying two x's, they're the same base, they're both x, you will add the 4 and the 2, so that will give you x to the sixth power. Okay, if you're multiplying numbers with the same base, you add the exponents. So if you look at the example, x to the a power times x to the b power equals x a plus b. When you multiply numbers with the same base, you add the exponents. Okay? Also, you can raise a power to a power. So, if you can go down on the handout, you'll see x squared in parentheses raised to the fourth power. In this situation, since you have the parentheses, normally when you see parentheses, you know you multiply. So x squared is in parentheses to the fourth power. You will multiply the 4 and the 2, and that will give you x to the eighth power. Okay, for the next example, you see xy in parentheses squared. Since x and y are two different bases, but they're both in parentheses, you will distribute the squared to both bases. So it will give you x squared, y squared, which that would be your answer. Okay, and then when you're dividing numbers with the same base, you divide exponents. So if you go to the next example, it says x to the fourth power divided by x squared. In this example, you would subtract the exponents. So x to the fourth and x squared, you would subtract the 4 and the 2, which would give you x squared. Okay, if you go to the second handout that I have provided, you will see it written sort of like a different way. It'll say review properties of integer exponents at the top of the paper. And you'll see the standard again, know and apply the properties of integer exponents to generate equivalent numerical expressions. If you look at the first example, product of powers, this is when you're multiplying. When you're multiplying numbers with the same base, you add the exponents. So a to the m power times a to the n power equals am plus n. If you move to the second one, the quotient of powers. When you're dividing numbers with the same base, you subtract the exponents. So a to the m power divided by a to the n power equals a and then m minus n. Okay, if you look at the third one, this is just the first power. When a number is just by itself and it has an exponent of 1, it just equals that number. You don't have to multiply, add, or anything. Like if you have 2 to the 1 power, the answer would just be 2. The 0th power. If you have a number and the exponent is 0, the answer is always 1. There's no exceptions. If you have 50 to the 0 power, the answer is 1. If you have 15 to the 0 power, the answer is 1. If you have 20 to the 0 power, the answer is 1. It will always be 1 if it has a 0 as an exponent. Okay, for negative powers, if you look at the example, it has a to the negative m power. When you have a negative exponent, you will always make it into a fraction, and it will be 1 over the number and the power, but you will always change that negative exponent to positive. So a to the negative m power will equal 1 over a to the m power. It was a negative m, but you put a 1 as the numerator and then change the negative m to a positive m. Okay, the power of a power. When you have a number in parentheses, a number and an exponent in parentheses, such as the example given, it says a to the m power, which is in parentheses, and then it has n outside of the parentheses. Parentheses, you multiply. So in this situation, you would do a m times n. So if you had, say, 2 squared in the parentheses and then squared again outside of the parentheses, you would multiply 2 times 2 and it would give you 2 to the 4th power. You would multiply the 2 exponents. Okay, power of a product. If you look at the next example, it has AB in parentheses. Those are 2 different bases. And then it has M on the outside. Since A and B are 2 different bases, you have to distribute the exponent to both of them since they are different. So you have AB in parentheses and M as the exponent. Your answer will be AM times BM. You will distribute that M to each base since they are different. For the last example, power of a quotient. This is where you're dividing numbers. You see it says A divided by B to the m power. That m will go to the A and the B since they are different bases. The worksheets provide the notes that I just went over. It breaks it down for you on the handouts. Like one example says b squared times b to the 3rd power. It shows you 2 b's, 2 letter b's, like it has b times b in parentheses, and then it has b times b times b in parentheses, and to add those. So just go through the notes or go through the handouts. It shows you in different ways, explained how to do it. If you have any questions, just email me. Thanks.